Hello again, everyone. So now we're going to be talking about how to graph linear equations. When we're graphing linear equations, we can graph them when they're either in standard form or slope-intercept form. So we'll go through examples in both cases. It is easier to graph them when they're in slope-intercept form. So sometimes what we'll do is just convert the standard forms to slope-intercept forms before we graph them. But let's go ahead and just get started with an example. So what we want to do on this one is we want to graph the line y equals 2x. Now, if you remember, this is in slope-intercept form, and we have the slope-intercept form is y equals mx plus b. So if you remember, the m stands for the slope of the line, and then the b is the y-intercept. So what we're going to do when we graph this is we're going to start with that y-intercept and plot that, and then plot the slope based on that, and then just connect the points. So in this example, we don't actually have a y-intercept because it's just y equals 2x. I could even write like y equals 2x plus 0. So we knew that like this was the b and then this was the m. And so like I just said, we're going to start with our y-intercept. Well, the y-intercept is 0, which means that I'm going to just put this point on the y-axis at 0. Okay, then we're going to find our slope, and our slope is 2. Now, if you remember from the slope video, we know that slope is rise over run, right? So I could even write this slope. If I know that the slope is 2, let's see, slope, I can write that as 2 over 1. Because any number I can put over 1 and it still stays the same, which means that this 2 is my rise, and the 1 is my run, which means from this point that I just plotted, my y-intercept point, I'm going to rise 2 and run 1. Rise 2 and run 1. And I could continue to plot up and up and up, or I could even go backwards. Instead of going up 2 and over 1, I could go back 2 or down 2 and backwards 1. And you can plot as many points as you want, or as many points as the graph allows you, but then all you have to do is connect the dots. And this is my line. That's how I graph it. Ta-da! Okay, so let's go through another example. This example we're going to say is y equals negative 2 over 5x plus 3. Okay, so once again, we're going to say that this is our slope, this is our y-intercept, and this slope already started as a fraction, so we don't need to kind of worry about that. We know that this is the rise, and then the 5 is the run. Okay, so let's draw a graph. And okay, so this y-intercept we decided is 3. So on our y-axis, which is the vertical axis, I'm going to go up 3 and put a point on that y-axis. Now, from there, I'm going to figure out my slope. So if you notice, the slope is negative. It's negative 2 over 5, which means that instead of going up 2 or rise 2, I'm gonna go down 2. So down 2 and then run 5. So go over 5. 1, 2, 3, 4, 5. And there we go. Like I did on the last example, I could continue to go down 2 and over 5. I could even go backwards or go up 2 and backwards 5 and plot a point. But really, all you need is 2 points to figure out what the line's going to look like, and this is the line. All right, so now that we kind of figured out how to graph when it's in slope-intercept form, let's talk about how to graph when it's in standard form. So the next example I have is 2x minus 4y equals 8. All right, so I'm going to show you 2 different ways that you can do this. With this example, we're going to do it with intercepts. So on the slope-intercept line, or on the slope-intercept form of a line, we know the y-intercept, like it's that very last number, the thing without the x. But we don't necessarily know what the y-intercept is on here. There's a way that we can figure it out. To find the y-intercept, what we have to do is plug in 0 for x and then solve for y. So I'm going to just write y-intercept. what I'm going to do is plug in 0 for x, so I'd have 2 times 0 minus 4y equals 8, and then solve for y. So 2 times 0, we know is 0, which just cancels that out, and I get negative 4y equals 8. Okay, I can divide each side by negative 4 to get the y by itself, and I would get y equals negative 2. So that's my y-intercept. Cool thing about this is that we can also find the x-intercept the same way, or the opposite way, I guess I should say. So to find the x-intercept, what I would do is instead of plugging the 0 in for x, I'm going to plug the 0 in for y. So I'm going to say 2x minus 4, but I'm going to plug in the 0 for y, equals 8. And once again, the 0 just cancels that second chunk out, so I get 2x equals 8. To get the x by itself, I'm going to divide both sides by 2. I end up with x is equal to 4. So that's my x-intercept. Now, just based on those two things, what I can do is actually graph this. So I'm going to draw a graph. Now, I just told you the y-intercept is negative 2. So on my y-axis, I'm going to go down 2 from the origin and plot a point. And then I also know my y-intercept, or I'm sorry, my x-intercept is 4. So I'm going to go 4 to the right of my origin and plot a point. And watch this. We can just connect these two dots. And this is my line. All right, so that's one way we can do it. We can do it with intercepts. And if that works for you, that's great. You do it that way. I'm going to show you with just one more example how to do it a different way, just in case you're not super fond of that way. Okay, so in this case, like I said, we could use intercepts, but I'm going to tell you if you were to use intercepts in this case, you would end up with some fractions, which isn't the end of the world, but it is a little bit harder to work with. So instead, what we're going to do is take this and convert it to slope-intercept form by just solving for y. So I'm going to solve for y by getting rid of the x first, and the way that I do that is by subtracting it from each side. So I end up with 5y equals negative 3x plus 10. Okay, then we still want to get the y by itself, so I've got to divide each chunk by 5. All right, so we've got y equals, because the 5's cancel each other out, negative 3 divided by 5, that won't simplify, we're just going to leave it as a fraction. And then 10 divided by 5 gives me 2. So y equals negative 3 over 5x plus 2 is my slope-intercept form. Okay, so now, based on those first two examples that we already went over, we should be able to graph this pretty easy. So my y, this is my m, and this is my b. All right, so we know we have to start with our b, our y-intercept, which means we go up 2 from the origin and plot that point. And then our slope is negative 3 over 5, which means my rise is negative 3 and my run is 5. Notice how I always attach the negative to the rise. You don't necessarily have to do that, but it's the easiest way to do it, because I always want you to think about going towards the right when you're graphing, because like I talked about in a previous video, we read a graph like we read a book from left to right. And so I always want you to make that run go to the right and attach the negative if there's a negative to the run. So we're going to attach the negative to the run, which means that the run is negative 3. So I'm going to go down 3, 1, 2, 3, and then run 5, 1, 2, 3, 4, 5 to the right. Now I've got my 2 points, and all I have to do is connect the dots. And there we have it. There's the line. And that is the second way we can graph standard form equations. So whatever you feel most comfortable with.